Hello Zoya, how are you?
I'm good.
Okay, how's your vacation?
It's going well.
So hope you are learning from your home.
Yes.
Okay, dear, very good. So can you recall the name of the chapter that we have currently discussing?
Yes, permutations and combinations.
Very good, dear. So can you remember the topics we have discussed till now?
Yes, permutations, and we also did some questions based on permutations.
Very good. So can you tell me the equation to find the number of permutations?
Yes, n factorial by n minus r factorial.
Okay, dear, very good. So I am presenting a screen to you. Okay, a PowerPoint presentation.
Okay.
Okay. So, as the name of this chapter indicates, it's not just about permutations, okay? It's about permutations and combinations. Hmm? From today onwards, we will discuss about combinations and we will discuss some problems about combinations. Okay? So, in this class,
Okay.
I will not tell you the exact definition of combination or I will not tell you the equation to find the number of combinations. Instead, we will discuss the difference between permutations and combinations and you have to figure it out the correct equation to find the number of combinations. Okay?
Okay. Okay.
So, are you ready?
Yes.
So, I have prepared some set of questions. In the first set, you can see the first sub question is how many arrangements of two letters can be made from the letters A, B, C, and D, and list out the possible arrangements. Okay. In the second question, here I just replace the word arrangement with combinations. Okay.
Okay.
Can you see the
Yes.
similarity between these questions? Here the situation is same.
Yes.
Yes. Okay.
Yes.
Here the situation is same, but the first sub question asks us to find the arrangements, and the second question asks us to find the number of combinations. Okay. In the third sub
Yes.
question, they ask us to compare the number of permutations and number of combinations. Okay. So
Okay.
similarly, I have prepared a second set of questions. In this question, they have asked us to arrange three letters that can be made from the letters A, B, C, and D, E. So in the second sub question, I have, as in the previous, I have just replaced the word uh, arrangement with combination. Okay. So can
Okay.
you see the similarity between these questions
Yes.
and the difference between them?
Yes.
Okay. At last, we will discuss the equation to find the number of combinations. Okay.
Okay.
So,
Okay.
let's move to our first question. Okay. So, the question asks us to find the number of arrangements. Okay. Number of arrangements of two
Yes.
letters that can be made from A, B, C, and D. And we also need to list out the possible arrangements. Okay. So,
Okay.
please tell me the equation to find the number of arrangements. So, what does this
Now,
arrangement means? Okay, arrangement
it
means
means we have to find
we have to find.
permutations.
Okay, dear, very good. Okay, we know that permutation is another word for permutation, right?
Arrange.
Yes.
Yes.
Okay. So, please tell me the equation to find the number of permutations.
N factorial by n minus r factorial.
Very good, dear. Okay. N factorial by n minus r factorial. Okay, thank you. So we will just indicate it as NPR, right? Number of permutations. N
Yes.
factorial by n minus r factorial. Okay. So
Yes.
So what does the n means? N means?
N means a number of items we can choose from.
Okay, number of items we can choose from, or we can say number of choices, right?
We
Okay. So how many
yes,
choices we
yes.
have in this question?
We have 4 choices.
Okay, dear, very good. Because we have four choices A, B, C, and D. So here n is equal to 4. Now, can you tell me what does the
Yes.
R means?
R is number of events.
Okay, R means number of events. So,
Events.
here what is the R?
R is 2.
2. Very good. Because here the event is to create the first letter and the second letter, right? In the 2 letters, the first event is to create the
Yes.
first letter and the second event is to create the second letter.
Yes.
So we have 2 events, right? So here R is equal to 2. Now just
Yes.
we need to substitute the values of N and R to this equation. Okay?
Yes.
Am I correct? So can you please substitute those values for me?
Yes. Yes. 4 factorial by 4 minus 2 factorial.
Okay, dear. Very good. So 4 factorial by 4 minus 2 factorial equal to 4 factorial by 4 minus 2?
2 fact
2
2
factorial.
factorial.
Okay, 4 factorial by 2 factorial. Here I can write 4 factorial as 2 factorial into 3 into 4, right? Okay.
Yes.
So by writing 4 factorial as 2 factorial into 3 into 4, I can just cancel the 2 factorial and 2 factorial. Okay? We can cancel the 2
Yes.
factorial. So we will
Yes.
get the number of permutation as, the final answer is
12.
12. Very
12.
good, dear. 12. Okay. So we have got our number of permutations. That is the number of arrangements as 12. Okay, very good.
Yes.
Okay. Now we need to list out those arrangements. Okay. So we have already found
Yes.
there will be 12 arrangements. Then now we will just list that arrangements. Okay. Usually they don't
Yes.
ask us to list the arrangement, but in this case I just added that question so that we can find those difference between the number of between permutations and combinations. Okay, so you don't need to worry. They
Yes.
don't usually ask to list out the
Okay.
arrangements. Okay, so
Okay.
can you please list out those arrangements for me?
Yes. A B
A B, then
A
A C.
A C
Okay.
A D
AD, then
B A
BA,
B C
BC,
B D
BD. Okay. Now, this is not enough. We need 12
C
arrangements. Okay. CA,
C A
then
C B
CB,
C D
CD,
D A
DA,
D B
DB,
D C.
DC. Very good, dear. Very good. Very good. So, we have listed out those 12 arrangements. Okay? Very good. Very good. So, we have completed our first sub question. Now, we can move to the second. Okay? So, here the situation is same. But, we don't need to find those arrangements. We just need to find the combinations only. Okay? Okay, right?
Yes.
Yes.
Okay.
So I am just casually asking that is what does this combination actually mean? Is it that exactly equal to arrangement?
No.
No. Here the combination means we just need to combine two letters. Okay. Here order is not a issue. Order is not an issue.
Yes.
Okay. In combination, as we can see in the permutations, if we look at those list of permutations, we can see that there is an AB and BA, right? Okay.
BA.
Okay. But in
Yes.
combination, we don't need both of them. Okay. Because we already combined A and B. So we got AB. Now it is
Yes.
not necessary to write
Yes.
BA. Okay. Because we only need combinations. We don't need to arrange those letters. Okay. Our aim is to
Yes.
combine two letters. That is, we already combined A and B. So we don't need to rearrange it as BA because it's not our aim. Okay. We just only need to combine A and B. So AB is enough. We can avoid BA in combinations. Okay.
Okay.
So from this list itself, we can list out those combinations. Okay. So here
Okay.
I am writing the list of combinations. The second B question answer. List of combinations. Okay. So we can just copy it from the first slide itself. AB. So we have AB. Okay. As AB. We combine A and B. Okay. Now we don't need BA, right? So we can just cancel BA here. Okay. Now we will write AC, the list of combinations.
Yes.
Okay. So now which permutation can we avoid?
Answer
We can cancel
CA.
CA. Very
CA.
good. We don't need CA. Now we can, so we already write AB and AC. Now what we need to write? We
Yes.
can write AD, right?
AD.
Yes.
Yes.
AD. Okay. AD we have already wrote. Which permutation can we cancel?
DA.
Very good. We are cutting off the DA. Now, can we, which one we will write next in the combination?
BC.
Okay, very good. BC. So we are cutting down the BC here. And BC already written. Now, which one can we cut it down from the combination?
CB.
CB. Very good. Now which one? Now what will we write in the combination?
BD.
BD. Very good. So we have BD here. We can cancel which element?
DB.
DB. Very good. Now the last and final element is
CD.
CD. Very good. Okay, we are writing CD here. Sorry. CD here. Okay. And we can cancel DC, right? Okay.
Yes.
So here we can see that we have got a list of how many combinations? Number of
1, 2,
combinations?
3, 6.
6. Very good. We have got
6.
a number of combinations as 6. Okay, very
6.
good. Number of combinations as 6. Very good. Okay, now it's clear that number of permutations is 12. Number of combinations is
Yes.
6. So,
6.
number of permutation is NPR is equal to 12 and combination we indicate as N NCR. That C indicates combinations. Oh, okay. So NCR is 6 here.
Okay.
Now, can you tell me the difference between NPR and NCR? Okay.
NPR is greater than
Great.
NCR.
Okay, it's very correct. NPR is greater than NCR. Then, what can we say about the ratio of these numbers?
It is 2:1. 2:1.
Okay, 2 is to 1. Okay. Or we can simply say that NCR is a half of NPR, right? NPR by 2. In this case,
Yes.
it is NPR by 2.
Yes.
In this case, it is NPR by
Yes.
2. Now, we can see that this 2 indicates the R, right? R, here we have got the
Yes.
R. But here there is some problem because we cannot really distinguish whether this 2 indicates 2 or 2 factorial. We are not sure exactly because 2 also is 2
Yes.
and 2 factorial is also 1 into 2, 2, right? So we need
Yes.
to confirm that whether this 2 is actually 2 or 2 factorial. Okay?
Yes.
So in this case, we will just conclude that NCR is equal to NPR by 2 and here the 2 is actually R. Okay? But we need to confirm it is whether R is R factorial or just R. So for that, I have also prepared a second set of questions. Okay? From that question, we can really confirm whether NCR is NPR by R or NCR is NPR by R factorial. Okay?
Okay.
So, sometimes there is a chance of NCR to become NPR by R, but there is a higher chance of becoming NCR equal to NPR by R factorial. Okay? So, let's move to the second set of questions. Here they ask us to arrange 3 letters. Okay? That can be made from the letters A, B, C, D, and E. Okay? So, can you please tell me again the now equation to find the number of arrangements, that is permutations.
N factorial by N minus R factorial.
Okay, very good. NPR is equal to N factorial by N minus R factorial. Very, very good here. Okay, here what is N?
N is 5.
5. Very good. Because we have 5 choices here, right? A, B, C,
Yes.
D and E. Okay, we have 5 choices.
Yes.
And what's the R here?
3.
3. Very good. Because we need to arrange 3 letters. That is first letter, second letter, third letter. So here the number of events to be created is 3. Very, very good. So now we just need to put this value in this equation, right? NPR equal to what?
5 factorial by 5 minus 3 factorial.
Very good. That is equal to
5 factorial by 2 factorial.
very good. Now, how can we replace that 5 factorial so that we can cancel 2 factorial?
We can write 5 into 4 into 3 into 2 factorial by 2 factorial.
By 2 factorial. And we can easily cancel those 2 factorial, right? Okay.
Yes.
So, what we got the value?
We got 60.
60. Okay. So, it may be a little hard for you to find those. List out the possible arrangements. But we can give it a try, right?
Yes.
So, I will erase those so that we can simply find those arrangements. I will also help you because there is 5 letters and we need to arrange it in 60 different ways, right? Okay.
Yes.
Not a big deal, but we can do it. Okay. As I said,
Okay.
they usually don't ask us to list out the arrangements, but here we are writing this because we can find the difference between those arrangements and combinations. Okay. So first of all, we can
Okay.
write what?
AB.
AB. 3 letters, right?
Yes. Oh yes, yes. ABC.
ABC.
ABD.
ABD.
ABE.
ABE. Then we will go for A. Hello.
ACB.
ACB. Then
ADB.
ADB. Okay.
AEB.
AEB.
Uh, then we can start with B, right?
Okay, we can start with B itself.
BAC.
BAC.
Then um, BCD.
BCD. Then
BCE.
BCE. Okay. Then I will say, like, I will help you to find those some of the arrangements. So next we can write the BAC. Okay. Now we can write BDE, right? Okay. And we can write BED. And we can write BDC. And we can write BCA. Okay. Okay. And we can also write okay, here it's complete. Now we can start from C. Okay. Can you tell me some arrangements?
Okay. CAB.
CAB.
CBA.
CBA. Then hello.
Oh, sorry. CBD.
CBD.
CDB.
CDB.
CDE.
CDE. Sorry. CDE.
CED.
Okay. So CDE. CED. Then
CD. CDE.
CD
All right.
is also
Okay.
there.
Yeah. Okay.
We can write CAE, right?
Then
CAE and
yes.
CEA.
EA.
Okay, CEA. So we got 1,
A.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13,
Then
14, 15, 16, 17, 18, 19, 20, 21. Okay, now we can start with D. Okay?
okay. This one we can also write CBE
CBE,
and CEB.
CEB. Okay.
Yes,
Now starting with
and
okay.
then the C. One second.
Okay. I know it's tough for you, but
Some.
okay.
Okay, we can start with D then.
D. Okay. D.
DAB,
DAB.
DBA,
DBA.
DBC,
DBC.
DCB,
DCB.
then DCE,
DCE.
DEC,
DEC.
then DAE,
DAE.
DEA,
DEA.
DBA,
DBA.
DEB.
DEB.
Yes.
Okay. Now we can start with E.
Okay. EAB,
EAB.
then EBA,
EBA.
then EBC,
EBC.
ECB,
ECB.
ECD,
ECD.
EDC,
EDC.
then EBD,
E.
BD,
No, we cannot repeat the elements, right?
EBD.
Okay, okay, sorry. I heard EDD. Okay, sorry, EBD. Now,
Yes. EDB,
EDB.
then E no EA no EAD,
EAD.
EDA,
EDA. I think we got 60. Okay. 1, 2, 3,
okay,
4, 5, 6, 7. Okay. 1, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43. Okay, it's just 43. Okay, but we can do another thing. Okay, we can just see how many arrangements can we write from a single ABC. Okay, by using ABC
okay,
only, 3 letters ABC, so that we can figure it out
okay,
with one combination of 3 letters how many arrangements we can make. Okay, because it's
okay,
a
okay,
very big thing to write 16 arrangements. So we can just see
okay,
ABC, and there will be AC, CACB. Okay, now there is a
yes,
BCA.
yes,
Okay, now
yes,
we
yes,
can see an
C CAB,
EAB. Okay, 1 minute. EAB.
L CAB,
CAB. Yes, CAB.
uh,
Now we have
CBA,
CBA. Where is the CBA? Okay, here is the
yes,
CBA.
Bill, okay,
Okay, 1, 2, 3. Now You can also make one more, right? Where is that?
BAC.
BAC. But I think we have, okay. So, this is the only possible arrangements. Okay? We can make
Yes.
ABC, then we can just rearrange and write ACB, then BAC, BCA, CAB and CBA. So, with a combination of 3 letters, we can make 6 possible arrangements. Right?
Yes.
With combination
Yes.
of one letter, with the combination of 3 letters, we can make nearly 6 rearrangements, including that combination.
Yes.
Okay?
Yes.
Which means we can nearly say that this NCR is, here we need to list out the combination. We can just see that the number of permutations is actually what? It's actually, in this case, it is 6 into number of combinations. Okay?
Yes.
Right? Because with the combination of 3 letters, we can actually make an rearrangement of 6 arrangements, including that combination. Okay? Which
Yes.
means NPR is equal
Yes.
to 6 into NCR. That is actually NCR is NPR by 6. Okay?
Yes.
Okay. But here
Yes.
we have in the first sub-question we got that when we are having R as 2, we got NCR equal to NPR by 2. When we have R as 3,
Yes.
we got NCR equal to NPR by 6. But 6 is actually not 3, but 6 is definitely 3
Yes.
factorial. Right?
Yes.
1 into
Yes.
2 into 3 into 4 into 1 into 2 into 3. Okay. It's actually
1,
3
2, 3.
factorial.
Yes.
Okay. So we can write that NCR
Yes.
is equal to NPR by 6. That is NPR by 3 factorial. Okay. So in the first case
Yes.
also we can just, it is not actually 2. It's disguised as 2 factorial. Right? It's actually not 2. It's actually it's not 2. It's 2 factorial. Okay. So we can see that here the 2 is R. So this will lead to what? This will lead to NCR is actually NPR by R factorial. Okay? Because here the R
Okay.
is 2. NPR by R factorial. Okay? And is in this
Okay.
this is clear, very clear from this case. NCR is equal to NPR by R factorial because here R is actually 3. Okay? So we got the
Yes.
equation.
Yes.
NCR is equal to NPR by
NPR by R factorial.
Okay. Now we just need to substitute the equation of NPR here. What is the equation
Yes.
of NPR?
N factorial. N factorial by N minus R factorial.
By R factorial here. Okay. So we can write it as
Yes.
N factorial by N minus R factorial
Yes.
into 1 by R factorial.
R.
Okay. That is actually N factorial by N minus R factorial into
R factorial.
Okay. So now we got the perfect equation to find the number of combination given N and R. Okay.
Yes.
So it's not that
Yes.
tough. We only need to divide the NPR by R factorial to get NCR. Okay. So
Yes.
I think
Okay.
that you have understood the difference between the combinations and permutations, right? Okay.
Yes.
And you understand the equation to find the NCR, number of combinations?
Yes.
Okay,
Yes.
thank you very much for hearing me. Okay, and I think you will not forget the equation to find number of combinations, right? Because we work really hard
No.
for this. Okay, thank you, dear. Okay, very good. So in the next classes, we will discuss the problems relating to combinations. Okay.
Okay.
Okay. Thank you for hearing it out. Let's see in the next class.
Okay. Bye.
Bye.